Hello, I'm George Flew, and I want to welcome you to this series of videos demonstrating how you, utilizing plain vanilla AutoCAD in the simple but powerful 3D toolbox, can take advantage of the power of 3D substation design. I began using AutoCAD for substation design in 1983, and in the late 80s created my first 3D design. I retired with 43 years of experience in the electric utility space and numerous substation design projects. Since 2014, I have devoted over a man-year developing the 3D toolbox, which contains over 600 AutoCAD drawing blocks, including switches, connectors, structures, etc., and also numerous apps written in Microsoft VBA and AutoCAD Autolist. This is a remake of my second video. In my original video, using BricsCAD, I made extensive use of the dynamic UCS system, the DUX, DUCS. Unfortunately, I didn't realize till later that AutoCAD doesn't honor the DUCS system in the same manner, so I've had to make some changes to that. So this will reflect those changes. So I'm sure if you're an AutoCAD user, you'll notice that this is AutoCAD. If you've done 3D, then this is the familiar nav cube, rather than the look from cube of BricsCAD. With that being said, the first thing let's do. First thing I want to do is turn off this base layer and get some of that out of the way. And let's review right quick our substation layout. We've got two bays with an incoming 161 kV line, comes through an isolating switch, a breaker, a circuit switcher, another isolating switch, a cross bus, support structure, a 161 to 12 kV, a 30, 40, 50 MVA transformer, a 12 kV isolating switch, meter structure, a support structure with a station service transformer, and 3 outgoing overhead bays. So in our first video, we put in the structures and material in this second bay. And in this video, we're going to come back and we're going to lay in all of the bus work up to the power transformer. So let's, as we did before, let's go into our 3D view and zoom in. And so the first thing we want to do is make a quick determination on the size of these wire jumpers that we're going to be placing in this area. And to do that, we'll pull up our design data cheat sheet, as you may want to refer to it. It's got some excellent information on it. So if we look at it over here, we'll see that our 500 copper single conductor is good for 670 amps. 30 MVA at 161 is a little over 100 amps. And even if we got those parallel, that'd be 200. So we're in good shape with 500 MCM copper. Okay, well, first thing we want to do then is we need to start making our jumpers to connect up our equipment. We're going to go over here. You might notice, as you will in this, I've made a few changes along the way, a few upgrades, and I've cleaned up this the menu section a little bit. So we're going to go over here and open our Substation Units and Assemblies tool. And the other, we call it the block tool. So we're going in here to our connectors, and if we zoom in here, at the end of this pad, we need to put a terminal connector. So we'll go up here to our filter, and we'll put in TL terminal, and it's a cable to flat connector, and it will be a copper connector. And you'll see here we have a selection of copper connectors. One is a 2-aught to 800, which then is exactly what we need for our conductor. So let me go ahead and put that in. Let me point out, you'll see some changes over here. We'll get to these in just a minute. So once we've done that, then we can come back here and do a copy. And since it copies the last block inserted or unit inserted, we can copy it to all these connection points. We'll go ahead and copy one down here, and then we can, holding down the Alt key, this is one of the changes I've made, and rotate, you get a 180-degree rotation instead of having to rotate it twice. And then again, we can hit copy, and we can copy this once more to these other two locations. Now we get over here to our breaker, and we see that our breakers are something a little bit different. So here we can't just do an insert with this because our connector is in the X axis, as you see here, and if we do that, then we get something like that. If we rotate that in the let's do it in the Y axis, that's not that's not in any way. It's not even flat to the pad, and certainly it's at an angle. So in the former video using BricsCAD, we were able to take advantage of the dynamic UCS that would find the plane of that pad. Unfortunately, AutoCAD, it has a dynamic UCS mode, but it will only find the plane of a 3D object. And since this 3D object is embedded within a block, it won't find that. It's because it's embedded. So to get by that, then I have put in this 3-point insert, and then what it will do is allow us, you'll notice it sets both the node and perpendicular. So we want, of course, we want it to insert at the node, and to orient it, we're going to pick up the perpendicular to the top of this pad and then to the left, and make sure you don't get there's of course a line hidden behind there for the back part of the pad, and then you see it sets that in there just exactly like we want it. So we'll have to go through here and then do the same thing with these others. We can't copy these because they're obviously none of these pads are parallel in any way to each other. So we will do each one of these separately. Takes a little bit more clicking. I may have missed that one. I did. We'll undo that. I actually didn't hit that back line of that back plane instead of the front one, and it's pretty obvious when you do that. Okay, let's rotate around here, and let's get we'll get these bushings here where we can see them easily. And let's rotate them a bit more so we make sure we hit the right face. So we're going to again come back to our 3-point. I'm going to zoom in, make sure I hit these correctly. Okay, there we have all of our connectors in here. If we come up here to put our connector in here on our line side switch, and we kind of rotate this so you can see what we're talking about here. We got this group operated line side switch. Now I could use the 3-point, but I think we can just put this in with our regular insert, and it inserted it there at that node. We need to rotate it in the Y-axis one time, and I'm going to hold down the control key so that it actually rotates in the correct direction, proper direction. And then we can just use copy and copy that to these other 2 pads. So there we've got all of our connectors in. At this point, we're ready to put in our jumpers. So the first thing I'm going to do is go up here and pick a layer that corresponds to the jumper size we're putting in. So this layer has to be named XBUS. There's a prefix, and then 500 copper, so that when we put in the jumper, it knows the diameter of the 3D bus that it's putting in. So you see here we selected just these 2 nodes. Ignore that node out there that's sitting out there kind of in the middle of space right now. We can talk about that later, but for now, this is the simplest jumper that just goes from one point to another point, and it's just the important thing is hit the correct point. I'm going to select that so when I rotate it, it will rotate right around that. Let's go back here. And let's get this up here where we can kind of get to both ends of this. And so once again, we're just continuing on with our 500 jumpers. And we're hitting the node point that's on the end of that connector. If you looked at the previous video, that node point was located back here, and it's easy to miss that one and pick up. There's a node point right here at the base of this connector too, so it's easy to get the wrong one. So I've moved that node point, makes it easier to hit. And when it goes in and does the bill of material, it adds a little extra conductor on each one of these jumpers to make up for that. So we just continue on here. Some reason this jumper here is this connector here is in the wrong orientation. It's rotated, so I can just select it and do a rotate in the Z. Hold down the Alt to rotate it counterclockwise. And so that just demonstrates here that if we want to actually rotate a specific item, we can select it. It doesn't have to be the last one inserted. We can actually select an individual item and rotate it. And so let's go back up here to our menu, and we'll pick up our jumper and proceed on. And I'm just hitting enter. I'm hitting my right mouse button, which I have programmed to be enter, which you can easily do on your AutoCAD. And so by hitting enter, it just reissues the last command, which in this case was the jumper. So we come back over here, and the next thing we're going to need to put in is our bus from here to here. This bus will be a 4-inch rigid bus, which is the same thing we're using all through on the 161 side. So let's just go in here. On this end, we're going to need a clamp type connector. Excuse me. Let's kind of get these out in the open. A clamp type connector. So let's go back up here to our connectors. It's still going to be a terminal connector because we're terminating that pipe bus, but this is going to be a tube to flat. I'm sorry, it took me a second to even figure out what I was doing. We're coming from a tube bus to a flat pad, and here we're just going to go down here and pick the 4-inch. So we get terminal connector, tube to flat, 4-inch. We don't need that perpendicular. We'll just click that off. We've got the node on, and then we'll hold down our Alt key and hit rotate to rotate that 180 degrees, and then simply copy that 2 times to these other. And there we've got those connectors. These connectors were put in the previous video, so we've still got those there. Now we need to put in a path for this bus here, and that path can be made up of any kind of line type feature. It could be a line, a polyline, a spline. We'll keep it simple, and we'll put in a line. We need to first tell it what size this bus is going to be, and we tell it that by, again, setting the layer. And we've got a X bus 4AL, so that's 4 aluminum. And the default there is pipe bus. And so we're going to put in a line, and here will be the first time I've actually, I think, used an AutoCAD command by typing it in or selecting it from a menu or any such. So we're just going to say line, and we're going to put it there's a node on the back side of this connector, and we're going to take it to this node on the far side of this connector, and then hit enter to terminate that. And here we can just draw that line 2 more times. However, we can use a copy on that line, and it will copy that line from the start end of the line. And so we can easily copy that 2 more times, and now we've got our lines here. So the next thing we want to do is convert those lines to a bus, and we want to do that. We make a 3D pipe bus. It's mainly for looks. It doesn't add anything to anything else in the station except for the looks. The length of that bus is really determined by this line. So when we do this, we don't delete that line. I'm going to select these 3 lines that we want to convert. I'm going to go up here the bus icon and click it, and then based on the layer that those lines were on, they don't have to be the same layer that's showing up here. It's the layer that those lines were on. It will then draw a pipe bus the correct diameter, again based on the fact that it's 4-inch. It will only, you can select more than just those lines. It only uses lines that are on X bus layers. And let me just point out here that this line, if we go up here and open the properties, the properties window, we'll notice here where I've selected this, I've got two selected. One's a line and one is a 3D solid. And so that line we want to keep for a couple of reasons. One, we need that line for the bill of material, and the second, I'll show you right here. You'll see this. Let me spin this around just a little bit, and next I'm going to show you what's one of my favorite jumpers. So what we need is a jumper from this pipe to this pipe, from this bus to this bus, and generally I look at that as it's coming from the bottom one to the top one. So I labeled that a riser bus. Now you can go either way, but that's the way I looked at it initially. So if I go back up here to my jumpers, I come down here, I find that I have a riser, and you can see the icon kind of looks like that. So I'm going to come down here, and it needs to actually, to connect that correctly, it needs to find that line. So right there it's looking for the near point to that line, near O-snap. So that line has to be there, and up here it's looking for, excuse me, let me click that first, and up here it's looking for a perpendicular, which is right there. So those lines need to be there just to find the geometry. So I can do that, continue that across here, make sure I go to the correct bus. I've certainly done that wrong before. And so now I've got the three riser buses in there. I need connectors for those. And we'll see here that those connectors are T connectors. Let me put a T connector. This would be a tube-to-tube T connector, so you can see why we call it T connector, of course, tube-to-tube. And here's the aluminum 4-inch tube-to-tube connector. And in this case, we don't really want to go to the node. We're going to go to the end point of this line. There is no node up here. But there is an endpoint on that line, so we do an insert. And AutoCAD, if we're above the midpoint of that line, it finds that the top endpoint. If we're below it, it finds the bottom one. So there's the top one. We want to again rotate that one time in the Z-axis. I'm going to go ahead at this point, insert one at the bottom, and here I need to rotate that 180 degrees in either the X or Y. It doesn't make any difference. And I've got my two connectors there. Now I can select this connector and this connector at the same time, and where the copy, oops, we got the bus. I want the connector. The copy, where we've stated before that it copies the last unit inserted. If you actually select units, it will copy those units. And let me just, for demonstration, let me pick. Well, it doesn't make any difference. It will copy it based on the insertion of the point of the last unit selected. So in this case, it'll be the insertion point of this one. You'll see what I'm talking about when I do copy. So we're going to be looking for that top end of that bus line. And so there we've got our connectors put in. We've got our connectors here. The next thing we need to do is connect up to our transformer. I believe on the previous one we probably already had these connectors in, but they're not here. So let's right quick. It's a terminal connector, and it's going from a stud. We're going to a flat pad here, so it's a terminal connector. It's a stud to flat copper, and typically the stud size on these larger bushings, larger voltage bushings, is going to be 2.5 inch. Here again we've got node. Let's just take the end off so we don't get confused. and we'll go in here and we'll put that in there. Now I'm going to spin that 180 degrees, and I'll show you why. There's a node on that connector. If I'd left it, I'd had to spin the whole transformer around. This way I can just go in here, because what I need to put in here next is our terminal. I need to put again a cable to flat, and we're looking for our copper. Again, the 2-aught to 800, and we could put that in. We can just put that in here, and now we just need to rotate that once in the x-axis. And of course, I rotated it the wrong way, so I'll now rotate it 180 degrees, and so now we have the connector here for our jumper. Now I need to copy those, and again I want to pick both of them. I'll pick the stud connector second, so that when I copy it, it's going from the base of that base point of that stud connector, because that's what we're snapping to there. Now let's go up here. We need to put in our connector at the end of the bus, and that will be, this time this won't be a terminal connector. This will be a coupling connector, because we're coupling from one bus to another. We're going from a pipe to a wire bus, so we're going from a tube to cable. And here you'll see that I have a 4-inch 350 to 6 covers 350 to 600, which of course will catch our 500. Here we'll leave it on node point, because there's a node there. Insert, and of course it's pointed the wrong way, so we'll hold down Alt and hit Z. Do a quick copy. That's done. Now, at this point, to put in our jumper, we can't use, well, it depends on how we want to do the jumper. We can put the jumper straight from here to here, and then we'll have to come in here and tap this down to our lightning arrestor, or we can actually run our jumper through the arrestor, which is what I intend to do here. And so, first off, I need to tell it what size jumper we're going to put in, which is our 500 copper. And then what I'm going to use here is the jumpers command. I'm going to put a jumper through here and up through here, so that means I'm making more than one. Basically, we're stringing jumpers together, and we can string as many together as we want to. And when we get done, we will just terminate it with a return. So I'm going from this point to this point. You see it lays in this initial line, and I'm going straight over to here. I'm going to this point. And then I'll terminate that by just hitting enter. And let me just kind of rotate that around, because it looks like it's an awful abrupt change in that conductor. It's not as bad as it looks. So we will just continue that, and this time I will just to show, I'll go from the other direction. And there you go. Once again, we've done it, and then we'll do this last one. And there you see, then we now have our jumpers, and we have completed our connection from the line side, incoming line side, all the way to the transformer, which was, of course, our intent here. And so with that, we'll call that it on this video. You can refer to our other videos where we complete the load side of the substation. And if you have any questions, any comments, you can come back here to www.the3DUtility.com and look in the upper right hand corner for the contacts menu, and you can send me your questions, comments, whatever you wish. And I appreciate you sitting in and watching this. Thank you. Bye-bye.